Good morning. In this session, we evaluate the mercury cathode cell. Welcome. The mercury cathode cell is designed for the purpose of large-scale extraction of sodium hydroxide. In order to extract sodium hydroxide on a large scale, we need a mercury film and we need brine solution. Brine solution is concentrated sodium chloride. The concentrated sodium chloride is put inside a chamber where it undergoes gradual dissociation through the process of electrolysis. As the process continues, it precipitates mainly sodium and discharges chlorine pure gas. The discharged sodium is then interacted with the mercury film, and a reaction occurs through the process of amalgamation, forming sodium amalgam. Now, once sodium amalgam is formed, the next step is to dissolve the sodium amalgam in water. The dissolution process precipitates mainly sodium hydroxide as a pure substance and also yields hydrogen gas. So in a nutshell, in the mercury cathode cell, we end up producing three pure substances, namely chlorine gas pure, pure hydrogen gas, and pure sodium hydroxide. Remember, sodium hydroxide is a major solvent for many industrial processes. We can use sodium hydroxide in the water softening process. We can also use it in other chemical reactions to precipitate other required substances. So, in a nutshell, if you look at the diagram, this is a representation of the mercury cathode cell. On it, we have brine solution coming in. When the brine solution comes in, it undergoes the process of gradual dissociation, and through electrolytic induction, we find that there is a separation of sodium from chlorine in the brine solution, which apparently is conch. And when that separation occurs, the sodium formed is then interacted with mercury, and the mercury thereon undergoes amalgamation to form the substance known as sodium amalgam. So once sodium amalgam has been formed, we have said that it is dissolved in water, and then when it dissolves in water, the outright representation is of sodium hydroxide, hydrogen gas, and free mercury. Now, since mercury is expensive and toxic, it is recycled in the system to preserve it and to use it for subsequent chemical processes for further preparation of more and more sodium hydroxide, chlorine gas, and hydrogen gas. To begin with, we say that the raw materials for the mercury cathode cell are mainly brine solution, mercury film, and water, which happens to be a solvent. In my next clip, we are going to look at briefly the chemical reactions that takes place during the mercury cathode cell reactions. Thank you.